Yeah, I was up against a couple of pretty, popular speakers, so I'm really glad that you guys showed up for this talk. My name is Edwin van Wijk. I work in the Netherlands for a company called InfoSupport, and I'm going to talk to you today about how you get a grip on your microservices running in Kubernetes. I'll say that up front. It's a lot of Kubernetes in this talk, using a service mesh. Maybe by show of hands, who of you is already using Kubernetes in some form in production? Or, okay, quite some people. Because I assume that you know a lot about, or you know at least how Kubernetes works, and some of the concepts behind Kubernetes. I'm not going to go into that in this talk. So let's dive in. What are we going to do? First of all, we're going to look at why would you need or use a service mesh, because there must be a reason, obviously, for using that. Then we're going to look at the service mesh concept. What is it? What is a service mesh and what you can do with it? And then we're going to look at a specific implementation using Istio. There are several implementations out there. I'll name a few in the talk, but I'm going to use Istio for this talk particularly. And then we're going to do some demos, because I not only want to show you slides. I only want to show you what you can do with the service mesh and actually show you how that works. And then we're going to look at observability. We're going to look at traffic routing or traffic shaping, and we're going to do some resiliency testing or chaos engineering, as it is also known in the industry. So why would you need a service mesh? Well, I've been using service meshes for some time now for a couple of our customers, and what we often see is that microservices is basically one of the more popular architectural choices nowadays. So distributed systems or microservices, but at least multiple parts that need to communicate with each other. And that's often how systems are built nowadays. And that gives you lots of advantages, obviously. We're not going to go into microservices in this talk, but there are talks enough about microservices. But once you've chosen that architectural style, not only you get the advantages, but also some disadvantages. And one of them is complexity. You get a lot of running parts. They have to intercommunicate with each other. We see customers with more than 100 services running in production, of everything very distributed, sometimes also with different technologies. So how are you going to manage all that? And of course, Kubernetes is one way of doing that, and Kubernetes has lots of cool tools to do that. But sometimes you need some additional control or some additional insights into what's going on inside that cluster. So to run these services, we need some controlled way of doing that. And then you see, practices like DevOps, containerization, which is obviously nowadays, almost everywhere. Things like infra as code. We want to do everything as code, so we can version it and we can put it into a version control system. And obviously also container orchestration, because if you have multiple containers that have to, collaborate, then you need some kind of orchestration. And that's where Kubernetes comes in. So what we see often during the last couple of years is that containerization is obviously very important and very popular. So, people start using containerization. They build a container. It's not business critical yet. It's some workload that they want to containerize. And then, they want to do more. It tastes like more. So they get another container, and these containers start communicating with each other. And then before you know it, you need something like an orchestrator. Well, Kubernetes obviously is one of the more popular orchestrators out there, so that's what I'm going to focus on in this talk. But as time progresses, more and more containers come in, and you get, pictures like this, or even bigger with even more services. And then the people that have to run these services, so the ops people or the DevOps teams that have to run these services, they look like this. What is going on here? How are we going to make sure that everything is up and running? If something goes wrong in this entire mesh, hence service mesh, where does it go wrong? Can I see that? Can I have telemetry, or can I, in one way or another, figure out where the issue is? So this is a problem. We need some more control than what Kubernetes can give us out of the box. So that is why you could opt for a service mesh. And this is the pun intended, right? Without a service mesh, you have a service mess. That's not always the case, but as you can see throughout this session, you can gain a lot more control over your services when you start using a service mesh. So what is a service mesh? Well, basically it is an infrastructure layer, and it will control all the communication between the services that are running in your cluster. And it does it basically on a network level. So that's also what the name comes from. It's a mesh that you basically apply on top of your Kubernetes cluster, and you can add all kinds of behaviors to the network at the network level. And by doing so, you can gain a lot of additional abilities because, these service meshes have all kinds of features, and I have a couple of them shown here, like security. You can get MTLS security between the services. You can do traffic shaping or routing, which we will do in the demo later on. But also observability, A/B testing, all that kinds of stuff, and also resiliency. Things like circuit breakers or retries, you can do that on a network level, so you don't have to do that anymore in your code, basically, if you're writing the code for the services. And there's lots more, so I'm going to show a couple of them today, but if you look at the documentation for the different service meshes, you will see that there's lots of features out there. So how does this work? Well, actually, the service meshes almost always work with the sidecar pattern. And the sidecar pattern is a very well-known pattern out there, which basically says we're going to run something alongside your application code, and that will take over all communication. So that sidecar will offer all kinds of capabilities. There is something new which is called ambient mesh, and that's something that is now under development. It's not production ready yet, for instance, for Istio, but that's something that's coming, and that basically eliminates the need for a separate container. It does things a little bit more, cheaper. It can do it with less resources, but as I said, it is not production ready right now. So for now, we're going to look at the sidecar implementation pattern. And what does this look like? This is a typical application running inside Kubernetes. Well, in Kubernetes, you schedule pods, basically, and pods can contain containers. And in this case, we have a web app calling into a couple of web APIs. And this is the normal way these communication lines are running. So, as you might know, Kubernetes also has networking infrastructure, so every pod can have a service and you can call into this service. This is basically the endpoint that you can call to communicate with, for instance, an API. Well, what happens when I add a service mesh to this? Well, then we see these sidecar containers appearing. So the pod will be expanded, an additional container will be run inside the pod, and then all communication will be taken over by this sidecar container. And this runs basically a proxy. If you know, for instance, Envoy. Envoy is a well-known open source proxy product, which is actually used by Istio. And this Envoy will be the proxy that will handle all the communication. Well, this is pretty invasive, right? Because all the communication will run to this sidecar container. But for your code, like the code running in the application container, it's completely opaque. You don't have to do anything for it because this is all done on the Kubernetes network level, right? So everything stays the same, but on the network level, things are configured differently. And because this is happening, and this is what we call the data plane in a service mesh, so this is where all the data between the application components will travel. And also, when we add the control plane, when we add the service mesh, we will get a control plane. And this control plane is basically, mission control for the whole service mesh. And the control plane can also communicate to all the proxies. And that can be both ways. So we can configure all kinds of stuff from the control plane, and this configuration will then be pushed to all the proxies to influence the behavior that they are doing. But also all the telemetry from all the communication is automatically pushed back to the control plane for observability. So that is that's where the power is basically of this approach. We will see this later on how this works in the sample application. So as I said before, there are several implementations of service meshes. So Istio is one of the more popular ones. It's used heavily out there, but also Linkerd, Console, Open Service Mesh, and Nginx Service Mesh. You also see lots of companies offering a service mesh nowadays. And most of them are open source. Sometimes they're not, but you have to look into that. And at the end, I also have some tips for you. Also, don't always go to one implementation. You have to look at all of them to see what is best fitting for your context or for your project. But for this session, we're going to focus on Istio. So what is Istio? Well, Istio is a complete service mesh implementation. It offers you lots of capabilities that we talked about, and it is basically built up out of open source components that you might already know. Like I said, Envoy, but also Prometheus, Grafana, Kiali. Those are all open source tools that are already out there, but they are combined into this service mesh offering. It is also a Cloud Native Computing Foundation graduated project. It has been around for some time. And basically what you do if you want to have this service mesh in your Kubernetes cluster, you have to install it, and it then adds a lot of CRDs, custom resource definitions to your Kubernetes cluster, and then you can add Istio configurations to your cluster. The cool thing is that it supports multiple protocols, so not only HTTP, but also gRPC, WebSocket, and TCP traffic. So one of the things that you will see later on in the demo, if I, for instance, in my sample application, I communicate with a RabbitMQ, and this RabbitMQ doesn't have a sidecar, it is just running in the cluster. But because I am communicating to RabbitMQ from services that do have a sidecar, I actually see this TCP level traffic showing up in observability. So that's an additional bonus that you get because all these communication protocols are supported. So this is a picture that I got from the Istio documentation, and here you can again see this data plane, what you see on top, like the Envoy proxy that will make sure that communication is possible between these two services. And you have this control plane that does all kinds of things like, well, discovery, configuration, certificates, and obviously the metrics for observability. This is a very simplified picture. Obviously, there are lots of running parts in there. If you want to know what actually is running under the covers, I would suggest to check out the Istio documentation. It's documented very well and very thoroughly, and you can find out everything you need to know about what's happening under the covers. So how do you get, once you have installed Istio into your Kubernetes cluster, obviously that will install these custom resource definitions, but also a couple of containers that are already running, which is the control plane. How can you make sure that if you have a container of your own, a service, a microservice that you want to run, that the sidecar will be added? Well, there are several ways of doing that. And one of those things is using the Istio control CLI. So Istio comes with a CLI tool. And what you can do is you grab your Kubernetes file, your Kubernetes manifest file, in which you describe your deployments and your services and all that stuff. And then you run Istio control kube inject. And you feed it this file, and then it will output a manifest file, and then add lots of annotations and stuff to make sure that once you apply this manifest file to your Kubernetes cluster, then everything is injected. So the sidecar is injected, all the configuration is handled, all the network level configuration is done for you. You don't have to do anything for that. So that is one way of doing that. But this is, of course, a little bit cumbersome because then when you want to make a change to this manifest file, you always have to do this inject step, and that is not really what I would suggest. So there is another way, and this is the preferred way, and that is using automatic injection, because Istio comes with an automatic injection capability. And what you then can do is through annotations that you can add to your Kubernetes manifest file, you can inject the sidecar. So what you can see, what I highlighted here in this code snippet, there's an annotation sidecar.istio.io/inject is true. And if the Kubernetes cluster has been configured and Istio has been added to it, then once you apply this Kubernetes manifest file, it will automatically add the sidecar for you and do all the configuration under the covers. So that's pretty convenient. And you can do this, for instance, for an entire cluster, or only for a certain namespace, or only for certain manifest files that you want to run. So that's pretty easy. This is also what I'm going to use in the demo later on. So speaking about this demo, I'm going to talk to you about a very simple application, because it's not about the application, right? It's about all the infrastructure stuff, and it's for a garage. And a garage is basically very simple. I've left out the part that you can also buy stuff at a garage, like the whole inventory stuff. But basically you have customers with vehicles, and they come in, and these vehicles can be serviced, right? You can change the tires or change the windscreen wipers or whatever. And I've created a simple system for that. And it was actually very hard to identify multiple services because it is so simple, but bear with me, it's all about the service mesh stuff. So this is a kind of a domain picture, very simple. I have customer management. Basically, I can add customers. These customers can have vehicles. A customer can, of course, have multiple vehicles. And then I schedule maintenance jobs for a certain vehicle, certain customers, and all the maintenance jobs in a certain day is the workshop planning. It's as simple as that. It is it's not a very elaborate application. So let me show you the application. It is actually running on my laptop. I'm running Docker Desktop here with the Kubernetes enabled. I've installed Istio, and I'm running now this application with the sidecars. So if I go to my browser, and I will go to the homepage. I'm a developer, by the way, not a designer, but you will see this quite instantly when you see my UI. And let me zoom in a little bit. Let me go. So this is the homepage. This is my awesome application. And then I have customer management. And I can add customers, so let me register one. Let me register myself as a customer. The keyboard is a bit slanted, so I might be making lots of typos, so I apologize up front. Well, street 1, whatever, this doesn't, 1, 2, 3, 4. Oh. Wow. So, I registered the customer, and I can see its details. Well, vehicle management, and I now actually putting some data in the system because I'm going to run a load test later on, and if I don't have any data, I won't see any traffic. So that's why you have to sit through this. I'm sorry for that. So let me register a vehicle. So S123 GB, it's a Volvo XC40, and it is my Volvo. So I can select a customer, but there's only one in here. So I register this customer, and now I can register a maintenance job. I can do that for several dates, so I can look back or I can schedule one in the future, but I want to schedule one for today. And I want to change the tires on my Volvo. And now I can select the vehicle. So, doesn't it get any more interesting than that? And then once, when I am a mechanic in the garage, I can use the same system to say, okay, I've completed this maintenance job and there were no issues. Complete. And then it's completed, and that's all the functionality there. So this is basically the application. So let me go back, and what I'm going to do now, I'm going to go into Visual Studio real quick, and I'm going to start a load test, because what I'm going to do is I'm just going to fire HTTP request at the application, requesting the customers, the vehicles, and the workshop planning. So I'm going to start a load test and call it LT. And now it is running in the back, and that's something that we need later on. So when we go back to the slides, what is the, well, architecture? I hardly want to call it an architecture, but what is this application made up of? Well, we have the web application that we just saw. This is just an ASP.NET web application running in the browser. And it uses a couple of APIs. First of all, the customer management API, the vehicle management API, and the workshop management API. They all use a SQL Server with separate databases in there to store the data. And then there's some other stuff in there. There's a RabbitMQ and there's a notification service. That's not interesting for this talk, but you might see that in logging or in the metrics, so you know it's there. But that is not the focus of this talk. It's basically about the web application communicating with these APIs, and that's what we're going to dive into. So, what is the deployment picture if you look at this from a Kubernetes perspective? Well, first of all, we have the deployments, the web app, the customer management, vehicle management, and workshop management APIs. They all have a service because we want to call into them. And the web app will call into the services for the APIs. And then the end user, the browser, will call into the web app service. So this is what is deployed on the machine. But what I said, it is deployed using Istio. So I've added these annotations, and I will show you the manifest files in a moment. So actually, these services are running with sidecars on the machine. So this is what is running now with some other stuff behind it, but that's not really interesting. So make a mental picture of this, because this is what we're going to fall back on throughout the demo. So Istio. So Istio is running now, these capabilities. We're going to look at them in several steps. And the first one we're going to look at is observability. And the observability that comes with Istio, you can look through several tools. So you look at telemetry, so metrics and traces, but you can also look at logging. And these are the tools that are available. You don't have to install them all. You can choose that, but these are available right now. So first of all is Grafana, and this will give you lots of insights into telemetry, like number of requests, number of bytes sent, number of successful requests. Well, we're going to look at that in a moment. Kiali is very powerful. It will give you all kinds of information about the mesh, whether or not everything is configured correctly. If you see errors, you will see, red lines and all kinds of metrics around the success and the success rate of the requests. And Jaeger is basically end-to-end tracing. So you can get end-to-end tracing throughout your entire cluster. So, for instance, when I call into from the web app to the customer management API, and this will send a message to RabbitMQ, which will be picked up by another service. All those kind of communications are captured by Istio, and you will be able to see that in the traces, right? So let me go over to my browser again, and let me open up one of those tools, which is Grafana. And like I said, the application is now in the back. It is doing all kinds of requests. So I'm just mimicking a couple of users running in the background. It's not heavy traffic, but it's just to generate some nice metrics. So when I go to dashboards, you can see that there are several dashboards available here for Istio. And the first one is the Istio control plane dashboard, because that's also made up of several containers running inside my Kubernetes cluster. And you can see there's all kinds of metrics. And I'm not going to go over all these graphs, what it means, because some of them I don't even know what they actually mean. Yeah, to give you an idea that you can see lots of stuff here around what's going on in the control plane. Also things like resource utilization, how much CPU, how much memory, how much Go routines are being called, pilot push information. Pilot is also around discovery and all that kind of stuff. So everything that the control plane needs to do its job, you can see telemetry here, whether or not everything is up and running and what the performance characteristics are. And you might imagine that if something goes wrong in the cluster or something goes wrong with your control plane, this is the place to go, because it will show you where things are happening, what is going on, what is going wrong, etc. And obviously, if we look at scaling, because this is all Kubernetes, right? And one of the cool things about Kubernetes is that you can scale up and scale out. And of course, these metrics, you can also set alerts on them. So if you notice that, okay, my cluster is so busy, I need to add some additional resources, then you can get alerts from the Grafana dashboard if you want. These are pre-made dashboards that I'm showing you right now, but all these blades, I think they're called, or all these metrics, you can create your own dashboards. So it's all up to you. You can just create your own dashboards and then show them on a large monitor, for instance, with your DevOps team. That's what I see often at customers. So that's the control plane dashboard. But also there are, for instance, service dashboards. And because it knows about the services, because it's constantly tracking all the traffic between the services, you see these services that we have in our application, the customer management API. Well, like I said, the log server and RabbitMQ are in there also. So this TCP traffic is being selected or is being detected, but it's not running with a sidecar. But the customer management API and the vehicle management API, they are. And if I open those, you can also get a lot of information about requests, the success rate of requests, what are the workloads, what are the sizes of the requests, all kinds of information that is really helpful when you start troubleshooting if something goes wrong. Because, yeah, like I always said, if everything works and everything is up and running and your customers are happy, then this is nice. This is eye candy, right? It looks like you're in control. But once things start going wrong, this is actually where you get the value from, because you can see exactly what's going on and where you actually have an issue in the system. So like I said, request duration, request sizes, where requests are coming from, where requests are going to, all those kinds of metrics you can just get without doing anything. I haven't configured anything. This is just the default installation of Istio. And you can also, of course, customize this, but out of the box, this is what you get. So I think that's pretty powerful and pretty valuable. Another one is Kiali. And Kiali also gives you all kinds of information. And the cool thing is that Kiali is basically an open source telemetry tool or dashboarding tool, but they've added all kinds of knowledge about Istio. So it knows about, is it running with a sidecar or not? So if I, for instance, here go to applications, you can actually see all my services running. So the customer management API, but the audit log service is also a container, missing sidecar. So it actually knows, okay, this is running inside your Kubernetes cluster, and I have services communicating with this thing. That's why it picked up the telemetry. But it doesn't have an Istio sidecar. What's going on there? That could be deliberate, but from this dashboard, you can immediately see whether or not you have a sidecar running or not. The other cool thing, and this is obviously always very nice to demo, is that you get a graph for free from the entire application. And like I said, there's some other stuff in here, so I have a filter set up so that I can leave out some stuff. But if I show you this, this is actually an overview of the application. And if I add some additional features, like I want to see the traffic distribution, so what percentage of traffic is going where, and then for the demo purposes, of course, I want to see traffic animation. And then you actually see all the requests running through your system. And also when something goes wrong or a request is not handled correctly, you will see a red arrow. And you can also get all kinds of telemetry around what's going on. So if I pick, for instance, this one, the Workshop Management API, I get all kinds of information. Okay, it is healthy, it is in the pit stop namespace, how many requests per second. I even can get the traces of the individual requests, and I can drill down all the way to individual request level. So that is pretty powerful stuff. And we're going to use Kiali throughout the demo to show you what's going on in the cluster. Right? Finally, I'm going to show you Jaeger, which is also pretty awesome. And you can do all kinds of queries, but now I'm going to focus on the customer management API. And if I say find traces, then I can see all the traces that happen here. So if I open up one, you can actually see that the web application called into the customer management API. But if you have multiple hops behind that it calls into another service, you will actually see a complete breakdown of this call, right? So that's all about observability. I've also put Prometheus up in here because lots of stuff under the covers around observability is also powered by Prometheus, also an open source tool. So that's pretty cool. And it's basically also more and more working with OpenTelemetry, which is also a standard. So these are the tools that are used right now. But if you want to use different tools, you can actually get the data in a standardized format and then use your own dashboarding tool if you want. So the next feature that I want to show you is traffic routing. There's lots of ways you can do traffic routing within the service mesh. So here is the picture again of the application as it is running right now. And what I want to do right now is I want to introduce a new version of the customer management API. So I've created a second version, and this will if I query a customer, it will add loyalty information about the customer. There's some kind of a loyalty status, and then you get a gold, silver, or bronze medal showing in the front end. And I must say that the front end is already equipped for this. So it will just say, okay, if there's a loyalty in the data that I get back, I will show it, and else I will not show it. So it's already knowing about these two versions. And this is, of course, a very simple change, but this could be a completely new version with all kinds of changes that you want to bring into production. Well, obviously, you can just deploy this service and make sure that the end users hit this service, and then fingers crossed and hope that everything goes right. But you all know that might go wrong. We might have had all our unit tests and integration tests, but actually doing that in production is sometimes quite scary. And what you can do, for instance, with Istio is that you say, okay, I want to deploy this service, and I want the traffic that is coming in for the customer management API service. I want to mirror that to the V2 service, but I don't want to send anything back to my end users. They are all using V1, but I just want to mirror the traffic and see what's going on. And then obviously with these observability tools that I just showed, you can keep a close watch on that V2 service and see that everything is going right. And obviously if this service would, do transactions in a database, you have to make sure that doesn't interfere, right, with the normal production operation. But in this case, it's only queries. So bear with me, this is a simple scenario. But obviously, if your application is up to it, you can do all these things with all changes that you want. So what I'm going to do is I'm going to deploy this V2 service of the Customer Management API. And that also gives me the ability to show you some of these manifest files, how I'm going to do this. So this is this visible in the back? Yeah, okay. So this is the solution. I'm going to give you a link to the GitHub repo afterwards, so you can use this and you can play with this. And I've described how you can do the things that I'm doing right now. You can do them yourself. And you might recognize the Customer Management API, the Vehicle Management API, which is just ASP.NET Core Web APIs, right? There's nothing fancy, and they're running as containers on my machine. Interesting is this Kubernetes folder in here, because here you can see all the manifest files for the different services. And I will show you the Customer Management V1 manifest file. And this is nothing fancy. This is just a default Kubernetes manifest files for deployment. So in this case, what I said is we're looking at a deployment, Customer Management API V1, it's running in the pit stop namespace. Well, if you've done Kubernetes before, you will recognize this. Nothing fancy or nothing Istio specific about this. But for deploying this, I have used a different version of this manifest file, and I will show you that one. Oh, this is the V2. And this is basically the same file with one addition, and that's this annotation. And like I said, I'm using this auto inject functionality because of this annotation. When I deploy this to my Kubernetes cluster, automatically a sidecar is added. So that's the only thing that I needed to do to add this. Another thing to notice is that I have a separate service for this deployment, right? So this is basically the endpoint that I'm going to use to communicate with this service. And there's something particular about this one, because I am only routing traffic to V1. And this is something that I always do if I have a versioned way of deploying my containers. Because I have a V1, I specifically tell it to only route to V1 traffic. And this means that I can now deploy my V2 version without it being called. It will just only be, the deployment is being spun up in my Kubernetes cluster, but it will not get any traffic. So I will do that right now. And for this, I use just the kubectl, the kubectl CLI. So I'm going to say kubectl apply -f, and then I'm going to give it this Customer Management API V2 manifest file, which is basically the same as V1 with the annotation, but then it uses a different version of the container, which has the V2 functionality, right? So I'm going to apply this, and then it says deployment created. And the really weird thing is, if I now go back to Kiali, for instance, and we focus on the customer management service. So let me open that up for you. Here we go. We will never see V2. And why is that? Well, because there's no traffic being routed to V2. It will only pick it up once we have traffic that is going to the version. So that is why we don't see that here. So let me fix that. So like I said, we want to now mirror the traffic that is coming into V1, and we want to mirror that to the V2 version of the service. Well, in order to do that, you have to create what is called a virtual service. And this is something that is Istio specific. So I'm going to show you the manifest file, and this is the Customer Management API mirror. So what I do is I create two additional resources in my cluster. The first one is a destination rule. And this basically gives certain labels that I've added to my containers. I give that a name. So V1 will mean that I will target all the containers that have a label version 1.0. And V2 means I have that will target all the containers that have a label V2 of 2.0. And then, once I've created a destination rule, I will use that to create a virtual service. And as you can see, both these are Istio resources, right? This is not Kubernetes, but this is Istio specific. And this virtual service will basically be will be an overlay onto the service for the customer management API. It's also running in the pit stop namespace, and then I specify what I want to do, and in this case, on an HTTP level, so for all the HTTP traffic, and this is just web APIs, this is all HTTP, I want to route 100% of the traffic to V1, and I want to mirror 100% of the traffic to V2. And this will mean that it will get all the messages that come into V1, but it will never be sent back to the end user. Right? So I will apply this file, and I will do this like this. And then you see that the destination rule has been created and the virtual service has been created. And now if I go back to Kiali, what we will see, I'll zoom in a little bit. Let me lay this out for you. It's a little bit zoomed in. You will actually see that this now has a virtual service. This purple thing means that it has a virtual service. And if I click on the service, you can actually see here that it has request routing and it has mirroring enabled. So you immediately see that Kiali has all kinds of knowledge about Istio-specific stuff. It sees that it has a virtual service, it shows that in the graph, and it will show you what's going on there. Well, now there's one thing, because we don't see V2 showing up here, and that is because the service that I've created up front is still only sending messages to V1, right? So now I am able, because the mirroring is enabled, and now I can safely remove this and say, okay, start using V1 or V2 or whatever. You don't have to target a specific version anymore. Well, I'm going to apply this also. And then the service will be reconfigured, as you can see, configured here. And now if we go back to Kiali and wait a couple of seconds, we will actually see V2 coming up. And we will also see that traffic is flowing through V2 to the SQL Server, because it's actually querying stuff in the database, but it is never sending the requests or the results back to the users. There we go. So now I have introduced this service without hurting any of the customers. So if I now go, for instance, to the front end, and I open up customer management, it's just V1. Else I would see in the loyalty status here beneath the email address, and I can refresh as much as I want. I only get results from V1 because I'm just mirroring to V2, right? So that makes sense. But in the metrics, you can already see that this is going through the service. Okay, so now that we're pretty happy because the service didn't crash, we didn't see any error, so it's probably running fine, right? So we can go to the next step, and then we could just throw it into production and say, okay, just load balance over V1 and V2, and then all the users will get either V1 or V2, because that's the default implementation of the service. But I'm just a little bit more cautious, because what I want to do actually is I want to do a canary release of V2. And basically what I want to say is, give me 25% of the people, of the requests, I will send them to V2, and the other 75 to V1. Because if still something goes wrong, or if there's any other issues that I haven't foreseen, then I only impact 25% of my customers. And in this case, I'm using a percentage-based policy, but you can also say users from that use this browser, or that have this header, or there are several ways you can define how this traffic should be shaped, right? So this is the simple way using percentages. So what I'm going to do is I'm going to go back to VS Code, and I'm quickly going to show you what the canary release looks like, the manifest file. And also you see here the destination rule, that's the same, V1 and V2. And now instead of mirroring, I'm saying on an HTTP level, I want to have 75% to V1 and 25% to V2. And like I said, this is where you have several different choices to select the policy here. So what I'm going to do again, it's going to be a little bit boring to see me type all the time. I'm going to apply the canary one. And what you can then see is that the destination rule is unchanged, because it's the same destination rule, but the virtual service has been reconfigured. And if I go back to Kiali, we can instantly see that, because when I select the service now, and I look here at what's going on, now you can see it doesn't have mirroring, but it has traffic shifting. And it is now using this 25-75 rule to divide the traffic. And if we look at the distribution of the traffic, this will eventually, because this is always looking 1 minute in history, so this will eventually go to 25-75. And if I now go to the application and I refresh this page, this is V1, 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 V2. This is V1, this is V1, this is V1, V1. It's not exact science, obviously, but in roughly 25% of the times, I get an additional loyalty level. So that means that my web application called the service, and it was routed to V2, and it got back data with a loyalty level in there. So now 25% of the customers already see this new feature lighting up in the front end, right? To take it a step further, what we can do now is we can say, well, you know what? I want everyone to enjoy this. Let me just remove the virtual service, right? So what I can do, and I can use the same tool, kube control, to remove stuff. So I can say delete, and then I will remove this canary release one. And what this will do is it will change, because now the distribution will be 50-50, because that's the default behavior of a Kubernetes service. It will just, load balance between the two services. So if I now go back to the application, I probably see more V2 calls than before, and that's actually the case, right? Well, and then the last step basically is, why would we use V1? Because everyone wants this new cool feature, right? So we can now just remove V1 from the cluster, and then everybody will use V2. So I'm going to do the same thing, kubectl, delete, -f, and then I'm going to just delete the V1 Istio service, deployment, sorry. The service will obviously still exist. So V1 is now deleted. And if I go to the service here, I can refresh now as many times as I want. I always get V2. And then in Kiali, if we wait a couple of seconds, then V1 will eventually be gone from the entire cluster. And everything is done with zero downtime. So all requests that are being made will be routed, and nothing will break. So, and that's because the Kubernetes and Istio will make sure that everything is handled correctly, and then the service will be taken out of the cluster, right? Okay. Next topic, chaos engineering. Who has heard of chaos engineering? Okay, a couple of people. Well, chaos engineering is basically, I think it was somewhere coined at Netflix at some point in time. They had this simian army in which they had all kinds of tools that they just let loose on production workloads, and they just, brought down stuff, and then they were just confident that everything kept working, which is, I think, pretty bold. If you can do that, you probably have your architecture pretty much under control. But this is something that we can also do with a service mesh. So one of the things that I've done for this application, in this web application, I've added resiliency. Anyone heard of Poly? .NET framework, or .NET library? So Poly is a framework or a library that you can use to build in retry, circuit breakers, all that kinds of resiliency stuff. So the resiliency, you want to test that. But we could, of course, just tear down the vehicle management API service in production. But that's a little bit scary, right? Because people are using it all the time. So how are we going to test this? Well, this resiliency is built upon the fact that when I do a request to the vehicle management, to any API, but in this case, we're targeting the vehicle management API. If I do a request to this API and it fails, then Poly will just say, okay, there was a failure, but I will retry. So what I now want to do is, using the service mesh, I want to introduce an HTTP 500 error or something else. You can send back a very big request, or you can introduce a delay, or any kinds of issues that you want to simulate, basically. You can do that using the service mesh. And it doesn't mean that the service is broken, but because all the communication is handled by the sidecar, by the proxy, they can just say, okay, the request went fine, but I will just return a 500. So the caller thinks that the service is down. And that's something that you can do. So what does this look like in Istio lingo? Well, let me close this up. We go to the vehicle management and then faults. And in this case, it's again a virtual service. So I'm adding behavior to the actual Kubernetes service. For the vehicle management API in the pit stop namespace. And what I'm going to say is, on an HTTP level, I want to introduce a fault. And the fault must be an abort of the request with an HTTP status code 500 or whatever. If you've written something that says, if I get a 404, I need to do something, well, whatever HTTP status code you want. And I want to do that in 25% of the time. So 25% of the requests will yield eventually an error 500. And like I said, again, there are lots of policies you can use here to insert issues, delays, timeouts, you name it. There's lots of stuff that you can find in the documentation that you can do to simulate all kinds of issues, to see whether or not the rest of your application and the rest of your architecture actually can handle that. So what I'm going to do now is I'm going to apply this to the cluster. Oh. And I'm going to throw in this vehicle management faults file. Here we go. Oh. Yes, so the virtual management API, virtual service has been created. So let's go back to, yeah, this is a little bit zoomed out. Can I zoom in here? This is the vehicle management. Yeah, this is it. So in a moment, and it is a little bit weird how this is shown in the graph, because it will show in a moment an additional vehicle management API service that will have errors. Oh, here it is already. Ah. But now you will see that the services, this one is already orange, and this is the web API, because the web API will get the errors. So that is what is showing here. And then you can see, if you look at the distribution, that the service not only has successful requests, oh, I'm messing up the zoom here, but we will also get error requests. And if I leave this on for long enough, then this will eventually go to 25%, because 25% of all requests will eventually fail because I've injected this fault on the network level. So if I now go to the application and I go to vehicle management, everything works. I can just open up, I find my Volvo, I can refresh, I can do that many times. It looks like everything is up and running from the front-end perspective. And this is what we want, right? Our customers doesn't need to know that there's something going on. But if I go to my logging, and I'm using, in this case, I'm using Seek to pick up all the logging from the services, and I focus on warnings, then you can see, and we could look at the timestamp, at a certain moment in time, you can see all kinds of errors. And it says, error occurred during request execution, poly will retry. Exception, response status code does not indicate success, and it will say it is 500. Can I hide this? Well, not indicate, oh, it's wrapping here. And you can see that this is actually the vehicle management controller that received that error. And then it did a retry, and then it got a successful answer back, so there's nothing wrong. That is why I don't see any errors from the front end. And now I can actually see that the resiliency that I've built into the application is actually working, because I've added these faults on a network level. Right? Okay. So those are a couple of features that you get out of the box when using Istio. And like I said, this is just the tip of the iceberg. So if you look in the documentation, there's lots of other stuff that you can do. You can have much more elaborate traffic shaping schemes. You can also, for instance, say these services can call into these services, but not into other services. You can do all kinds of security stuff. You name it. Everything that you can influence on a network level is basically available to you through the service mesh. So some final thoughts. Looking at this, you might think, I need this. This is pretty cool stuff. But like I said, with microservices, with Kubernetes, with everything that you introduce complexity, you introduce new things you have to learn. So make sure that you have a need for a service mesh. And also make sure that you have an architectural fit. Because like I said before, the introduction of the V2 service and my front end, knowing about V1 and V2 and being version aware and having all kinds of resiliency in there, that is why I could just introduce that this way. So don't think that this service mesh is some kind of a magic wand and that you say, okay, once I've included this service mesh, I don't have to think anymore as a developer about resiliency and all this stuff. No, you still have to have a cloud-native architecture that supports these kinds of things. Version awareness, backwards compatibility, all those things that you needed to think about before. You still need to do them, but now you get lots of value when you add this service mesh because you can do all kinds of stuff that I just showed you. Also think about the experience of your team. If you have a team that are purely developers and they don't have lots of understanding of networking and all that kinds of stuff, it can be pretty hard to know what's going on and to configure everything. So that's also something that you have to take into consideration. Of course, the experience with Kubernetes and what's going on there, because you still need to know what's going on there. Maybe you don't even have non-functional requirements, because it is pretty cool if you can do zero downtime deployments. But if your customers are accustomed to doing a release every Sunday and they're fine with it and they don't want to pay any more, leave it. It's fine. It's only when you need these non-functionals, then you need to look into this because it could help you to solve those issues. And finally, if you have deployment issues, so if you don't have any issues and everything works fine and everything is happy, then don't introduce a service mesh because it will only add certain complexity. So treat it as a tool and not as a piece of candy. Also, when you start working with a service mesh, really thoroughly go to the documentation. Most of the service meshes have pretty good documentation, which will show you what's happening under the covers. It will show you best practices, what to do, what not to do. So make sure that if you choose eventually to use a service mesh, read the documentation thoroughly, because that will help you in the end, and it will show you it will shield you for all the errors that others have made. Like I said, this whole sidecar thing is something that people have complained about, because obviously having a sidecar always introduces performance overhead. It can be very small, right? Because it's running in the same pod on a Kubernetes cluster, so it will not be milliseconds. But if raw performance is something that you need, if you're building some kind of a algorithmic trading application and you need all the performance you can get, then maybe using a service mesh is not for you, and you should solve it somewhere else in your code or on another level. Well, to overcome this performance impact, that is one of the reasons this whole ambient mesh thing is around. And most of the service meshes are looking into this. So if you're interested in this and you want to have the least amount of overhead, then look at ambient mesh mode. But that said, ambient mesh doesn't have all the features that you get from a sidecar deployment. So it is a trade-off that you have to investigate. And last but not least, I've shown you Istio. Istio is pretty cool. Linkerd is also pretty cool. I've added in the repository I'm going to show you. There's also Linkerd files, so you can use that. So shop around, see what's out there, but make sure that you know your requirements and then look at what is the best implementation for you. And also taking it into consideration what kind of project it is. Is it fully open source? Is it backed by a large company? And what is the customer that you're using it for? What do they want? Is it okay to use open source? Is it not? What is the policy there? So make sure that you take that into consideration. Okay, going to leave you with these 2 links. If you go to istio.io, you can get all kinds of information. You can get the documentation of Istio. And if you scan the QR code or you go to this link, this is the pit stop application. And within the pit stop application, there's a wiki that you can check. And there's a complete description on how to run this in Kubernetes with Istio. And all the files that I just showed you are in there, so you can get a start from that. Okay. Thank you so much, and enjoy the rest of the conference. I have some time for questions, so if anyone has a question, then I can do that. But if not, thank you so much, and enjoy.